So today's objective is you can solve multi-step equations. Yesterday we did two-step and we had a three-stepper, and today we're going to make sure we know some multi-step problems, finish up some vocab and notation notes. Okay, we'll have an assignment on Monday. So again, everyone's listening to me, not headphones in our ears, please. Okay, so on number one. Now, how is this different than what we've seen before? There's two x's, right? Okay, and yesterday, number 3, there was two x's on the same side, and we combined like terms. On this one, the x's are what? Different sides of the equal sign, right? So here's equals, x's on both sides. What should I do if x is on both sides? Okay, I should get rid of one of them, right? We can't have two x's. Remember, the point is to get one x by itself on one side. So you can actually get rid of either x and still get the right answer. But my suggestion is to get rid of the smaller x. Okay? We get rid of the weak. No, I'm kidding. But seriously, we get rid of the smaller x. Makes it easier because you'll end up with a positive x. So 3x is smaller than 5x. How do I get rid of a positive term, a positive 3x? We are going to subtract. So minus 3x, cancel that out. 5x minus 3x is 2x. Bring down, plus 7 equals 13. All right, next step. So this is a two-step problem like we did yesterday. What do I always get rid of first? The loner, the one that's by itself, which is the 7. How do I get rid of a positive 7? Minus 7 on both sides. So 2x equals 13 minus 7 is 6. And then to get rid of that 2 coefficient, we divide because it's being multiplied. So 6 divided by 2 is 3. Again, I'm modeling how you should, not exactly, okay, but in some way show your work each time so I can see what's going on. Okay. The second one, number 2. What's different about that? The parentheses, and there's a number in front of it. What do I do with that number in front of the parentheses? Okay, we're going to multiply it inside, and what's that called? Who's saying it? What's it called? Starts with the letter D. Distribution, okay? So, distribute. We're going to distribute the 3 into the x and the minus 2. So again, I like to draw little arcs to remind myself I'm multiplying everything. So 3 times x, 3x. 3 times the minus 2, negative 6 or minus 6, and bring down equals 9. Once again, we have a two-step equation. What do I always get rid of first? The loner, the one by itself. So I get rid of that minus 6 by doing what? Add 6 to both sides. Okay, 3x equals 9 plus 6 is 15. And then last step to get rid of that 3, we divide. Okay, so dividing by 3, x equals 15 over 3, which is 5. Okay. All right, and the last one. How's the last one different? There's a big fraction, right? Not just like the x is being divided, but the whole left side. So instead of getting rid of the loner first, we need to first get rid of the fraction by getting rid of the bottom number. What do you call the bottom number on a fraction? Starts with a D, but not dividend. Denominator, right? Down for denominator, up for numerator. So to get rid of this denominator, dividing by 3, what's the opposite of dividing by 3? Multiplying by 3 on this side, multiplying by 3 on this side. Both sides, right? So on the left, the 3's cancel out. I'm going to bring down that 2x minus 9 equals, and then 3 times 3 is 9. So once again, I have a two-step problem. I need to get rid of the loner first, the minus 9, by doing what? Plus 9 to both sides, plus 9, plus 9. Cancel that out. 2x equals, what's 9 plus 9? 18. And then, to get rid of that 2, we divide. So x equals 9. So, again, after today, I expect that you should be able to solve a one-step, two-step, and certain multi-step problems, okay? You will see algebra as we go through this, so you got to be able to set up something and solve it. Cool? So trying to prepare you to show me your work and solve for x. Okay, now do you have yesterday's notes for angles? I gave you a second page, and we apparently finished off on obtuse? No? What did we finish on? Okay, so we finished straight angle. Let's talk about the next one. Oh, here it is. Okay, so we did straight angle. Let's talk about adjacent angle, okay? All right, so adjacent is another way of saying next door to something, right next to something. So my next door neighbor over here, this lady, she's adjacent to me because we share a boundary. Our classrooms touch at a wall, a boundary. Okay, so two angles that are next to each other and touching. You can draw a little picture of that real quick for me. All right, next one is linear pair. So notice, a linear pair, in the name it tells you, linear means it makes a straight line. Pair, there's two of them. So two angles together that make a straight line, and they're adjacent. So they're touching, making a straight line. And if you're given one angle, you can get the other angle by subtracting it from a straight line, which is 180. Okay? So make sure you fill that in. Okay? Everyone have linear pair? Okay. So it'll be on the sideboard if you need it. Let's talk about vertical angles. So vertical angles are across from each other. I know vertical usually means up and down, right? But these vertical angles just mean across or opposite from each other. So if this is 158, across from it is going to be the same measurement, 158. And then to figure out the one adjacent next to it, these are a linear pair. Does everyone see that? Angle 2 and angle 3 are a linear pair. So together, these two need to make 180 degrees. So I did 180 minus 158, and that's how I got 22. If you're given one angle at an intersection, you should be able to find the other three. Not too bad. So that's your vertical angles. Let's talk about supplementary, okay? Supplementary angles, whether they're adjacent and touching or whether they're separated, the only thing you need to know is that they add up to 180 degrees. So if you're looking for one and you have the other, subtract it from 180 and that'll give you the missing angle. All right, so that's supplementary. Any questions on supplementary? Let's talk about the next one, complementary. Now, to figure out a missing angle for complementary, you just subtract the total, and you can tell this is right? This is 90 degrees. Subtract that 52 from 90. That's how I got 38. Now, do y'all know how to remember the difference between supplementary and complementary? Or how to tell which one's which? What's a good way to remember? Right. Yes. Okay. So you can see on the board here, 90 has a little C in it for complementary. 180 has a little S hidden in it for supplementary. That's one way. Here's another way you can remember. Ready? Hey, wake up. Check it out. Miss Morero, that's a nice red shirt you have on.
Oh, thank you so much, Mr. Gonzalez. What a nice compliment. It is right that you give
Wait, say that again.
compliment. Oh, thank you so much, Mr. Gonzalez. That is so right that you gave me a nice compliment.
Did you say right compliment? Like a right angle is 90 degrees?
That's exactly what I meant, yes.
90 degrees compliment, 90 degrees right. It's the right thing to do, compliment. All right, that's good. All right, I got a better one. How do you remember supplementary? Check it out. Sometimes I'll be walking down the hall, right? And someone behind me will say, hey, Mr. G, sup? And I'll be like, 180 degrees, sup? All right. Well, I tried. Next one. Reflex angle. Now, a reflex angle is going the long way. So you can see we have 35 degrees here, but if you go the Hello? All right. If you go the long way, looks like a Pac-Man face, that long, big angle is 325 degrees. That's the reflex angle. All right. So everyone has that down? Next one. All right. I'll spare you the song. Let's do these notation notes real quick. Okay. All right. Does everyone have this sheet? So we need to name 3 points. How do I name 3 collinear points? What does collinear mean again? What does collinear mean? Sorry. In a line. So where do I see 3 points in a straight line? What are those 3 points? Okay. A, B, and C are in a straight line. Okay. So again, collinear, and you name points with capital letters. A, B, and C. A, B, and C in a straight line, right? So that's collinear points. Any questions? If you're asked on how to do that, you're going to be able to name 3 different letters that are in a straight line, collinear. Yes? Okay, the next one is what? Naming rays. Thank you. What's a ray? Ray. 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 It has an endpoint, and it goes forever one direction with one arrowhead. So, now if you look at this, it doesn't look like there's any rays by themselves, but on these lines, a ray is part of a line. So we just need to pick 2 points. Which endpoint do you want to pick first? B, and then towards which way? E? B towards E? That's a ray, as long as you go forever. So, let's put these 2 letters, B, E. We always put what first? The endpoint. The endpoint is B, then E. What goes on top? Not a line, a ray. Okay. So we did the notation on the notes, the vocab. For rays, you have to put an arrow going to the right. Always to the right. Okay? Now, let me show you why. Let's say we pick another one, starting at C, going towards the letter D. Okay? Now, how would you name this ray? Okay? You might want to put DC because we think left to right, but you have to. It has to be endpoint first, which is C, and then D. So CD with the arrow always going to the right. This is the trickiest one that people miss, so don't miss that one. Okay? Endpoint first, then the other then the other letter for the point, and then the arrowhead going to the right. Okay? Number 3, name 3 line segments. What's a segment? Part of a line with 2 end points. So let's just pick 2 points. Give me some points here. A what? Oh, BD? Between B and D, no arrowheads? Yes, that is a segment. What else? Oh, what goes on top of a segment? On top of a segment, you should put a segment with no arrowheads, okay? Is everyone seeing that? If you put arrowheads on a segment, I'm going to mark it wrong, okay? The notation matters, very much so. Okay, what's another segment? B to E. And again, on top of it, I'm going to put a segment with no arrowheads. Last but not least, what else? A what? BA? AB, either way. As long as you have no arrowheads, that's a segment. Cool? Okay, you can flip that over. On the back, we have some examples. Now, what if they're asking you specific questions based on a little picture or a description? So number 4 says it's a segment with endpoints QR. It tells you what the endpoints are, so write those 2 letters down, Q, R. What has to go on top for a segment? A segment, which means no arrowheads. Okay? Does everyone hear me say that? Segments have no arrowheads. Don't put arrowheads on top. Okay? But number 5, what is that thing right there? That is a regular line because it has arrowheads. So I'm going to write these 2 letters, WZ. What goes on top? A line, 2 arrowheads. Do you see how that matches the picture? If the picture has arrowheads, use that. Okay? Now, 6 is tricky. What is 6? But what is it? Okay? What is that called? A ray. We always start with the endpoint. So this is D, and then goes towards C. Which way does the arrowhead go? always to the right, and it's a ray, so there's one arrowhead to the right. Okay? 7 is what? Okay, 2 endpoints is called a line segment. So I write the letters H and K, and on top I'm going to put a segment. No, doesn't matter, but yeah. Okay, we have a line with DE, so put D and E, and on top I'm going to put a what? Line with 2 arrowheads, right? Okay, now number 9, write your own question. If I were going to write a question, I'd put, let's see here, name 3 lines. And then you're going to answer it down here, okay? So you make up your own or do the 3 lines one, answer it over there, and that'll be it for the notes. The assignment we're going to do on Monday, okay?